It was 4 a.m. on November 25th at the summit of Hawaii's dormant Mauna Kea volcano, a place where the thin, cold air feels almost otherworldly and where the sky above seems closer than anywhere else on Earth. The observing team, bundled in thick jackets against the frigid winds, gathered quietly around the glowing screens inside the control room. Despite the early hour, there was a tangible sense of anticipation, something electric, something almost reverent. They were here not simply to look at another comet or routine celestial object, but to witness firsthand a visitor from beyond our solar system, an object that had traveled an unimaginable distance across the galaxy before briefly passing near our sun. The process of preparing to view the comet took less time than expected, and before long, the data began streaming in, pixel by pixel, from the instruments outside. On the main screen, the target of the night, the interstellar Comet 3 I/Atlas, appeared as a faint, fuzzy blob drifting quietly through a densely packed field of stars. To the casual observer, it might have looked unremarkable, just another dim smudge against the cosmic backdrop. But to the scientists and enthusiasts present, that faint smudge represented a relic from a distant star system, a messenger carrying chemical fingerprints and physical clues from a place humanity may never visit. On a second screen, its light had been unraveled into a long barcode of rainbow-colored lines, known as a spectrum. Some of the lines glowed brighter than others, each one corresponding to molecules and gases boiling off the comet's icy nucleus as it warmed during its journey around the sun. To scientists, those lines are like a language, one that reveals secrets about where the object came from, what it is made of, and how it has evolved over time. "This is some prime-time science happening in real time right now," said Bryce Bolin, the principal investigator leading the study of the interstellar comet. His voice carried a mix of calm professionalism and unmistakable excitement. As he welcomed a global audience tuning into the online skywatching session, his enthusiasm helped bridge the gap between experts and laypersons. The session was hosted by Shadow the Scientists, an organization dedicated to giving ordinary people direct access to real scientific research, and supported by the Gemini North Telescope, one half of the International Gemini Observatory. Through the live stream, thousands around the world watched as data from a distant, ancient traveler was captured and dissected second by second. But what the audience was truly observing on the control room screens was much more than a comet. It was a living time capsule, an ancient remnant of ice, dust, and rock that may predate the birth of our own sun by millions or even billions of years. This object, now drifting back out of our solar system, had wandered the galaxy for perhaps eons before accidentally passing within reach of Earth's telescopes. To imagine its journey is to imagine something profoundly humbling, a chunk of primordial material, forged in a star system that may no longer even exist, quietly traversing interstellar space in darkness and isolation, only to pass by our tiny planetary neighborhood on its vast cosmic voyage. By sheer chance, it approached our sun closely enough to be illuminated, measured, and admired before continuing on its path into the depths of space. This wasn't the Gemini Observatory's first encounter with 3 I/Atlas. Months earlier, in August, when the comet was still plunging toward the sun, the Gemini South Telescope in Chile had begun observing it. Those pre-perihelion images offered some of the earliest clues about its composition and behavior. As the comet warmed, its tail switched on dramatically, expanding and brightening with jets of gas and dust that streamed outward from its nucleus. The data revealed a composition distinct from that of most solar system comets. Instead of being dominated by water vapor, 3 I/Atlas released large amounts of carbon dioxide and cyanogen. This unusual chemical signature suggested that the comet formed under conditions different from those in the early solar system, reinforcing the idea that it originated in a foreign planetary environment with its own unique history. By late October, the comet had reached perihelion, the point in its orbit where it passed closest to the sun. It raced through space at an astonishing speed of about 130,000 miles per hour, moving faster than most objects ever seen from Earth. As it whipped behind the sun from our perspective, it temporarily disappeared from view, though not from scientific attention. Spacecraft positioned across the solar system continued tracking it during this period. Instruments aboard the Mars Reconnaissance Orbiter captured images of its glowing coma from a vantage point millions of miles away, and even NASA's Perseverance rover on the surface of Mars recorded glimpses of the comet as it streaked across the Martian sky. This rare interplanetary collaboration meant that while Earth-based observatories, such as Gemini, were unable to observe it during this phase, the comet's journey remained well documented from multiple angles within the solar system. Still, for the team on Mauna Kea, this night was their chance to reconnect with a cosmic wanderer they had briefly lost sight of. Now that 3I/Atlas had emerged from behind the Sun and become visible again from Earth, the Gemini North Telescope could resume collecting data, offering the first post-perihelion glimpses of the object as it headed back into the cold frontier of interstellar space. The faint smudge on the screen, though modest in appearance, carried with it the weight of countless scientific questions. How old was it? What star had it once orbited? What might it reveal about the building blocks of distant planetary systems? And how many more such interstellar visitors might be passing through our solar system without our knowing? Inside the control room, the atmosphere grew increasingly reflective as the session progressed. Observers spoke in hushed tones, aware that they were witnessing a historic moment in real time, a moment that bridged humanity's curiosity across continents, cultures, and generations. The live-stream chat filled with questions from viewers around the world, many of whom were seeing the raw data of an interstellar object for the first time. Some asked about the comet's speed, others about its likely origins, and still others about whether objects like this could ever pose a danger to Earth. Scientists responded patiently, explaining that interstellar comets are exceedingly rare and that most pass through the solar system without incident, though their scientific value is immeasurable. As more data poured in, the conversation shifted toward the philosophical. Observing something so ancient, so untouched by the processes that shaped our own solar system, naturally evoked a sense of awe. For many watching, the realization that such objects drift freely between the stars was almost overwhelming. It served as a reminder of how dynamic and interconnected the galaxy truly is. Every interstellar traveler carries with it the history of a place far beyond our reach, and yet here, for a brief moment, one of them was close enough for humanity to study with modern instruments. The experience felt like receiving a message in a bottle cast adrift across cosmic seas. The scientists also reflected on how the discovery of 3I/Atlas fits into a broader trend in astronomy. Only 2 confirmed interstellar objects had ever been observed before, Oumuamua in 2017 and Comet 2I/Borisov in 2019. With 3I/Atlas, researchers had a new opportunity to compare and contrast these rare visitors. Each object has been markedly different, suggesting that planetary systems across the galaxy may evolve in diverse and unpredictable ways. Whereas Oumuamua displayed unusual, possibly elongated geometry and puzzling behavior, and Borisov resembled a more typical comet, 3I/Atlas brought yet another set of mysteries with its carbon dioxide-rich composition. Together, these objects are reshaping scientists' understanding of what lies beyond the solar system and raising questions about how much more remains unseen. Outside the control room, the night sky over Mauna Kea remained perfectly still. The stars shimmered overhead in a crisp dome of darkness, untouched by the lights of cities far below. It was the kind of sky that ancient navigators once relied upon and that modern astronomers cherish. From here, human eyes and instruments can reach deeper into the universe than almost anywhere else on Earth. And on this night, that ancient sky bore witness to a scientific milestone, the direct study of material older than the sun itself. As the session drew to a close, the significance of the moment lingered. The comet, already speeding away from the sun, would soon fade from visibility entirely, destined to roam the galaxy once more. The data collected during these brief encounters would become part of humanity's expanding archive of cosmic knowledge, analyzed and reanalyzed for decades to come. For now, though, everyone watching scientists and citizens alike, had shared a fleeting connection with something profoundly ancient, something that had journeyed across the galaxy only to be seen by human eyes for a few short moments. It was a reminder of how vast the universe is, how small we are within it, and how extraordinary it is that we can reach out across such distances to understand even a tiny fragment of its story.